Welcome to another episode of Advanced Steel Modeling. Okay, today we are going to focus on creating Eaves Haunch and the apex connection on our portal frame. Now, if you take a look at on the right of the screen, we've got the haunch connection. That's the one that we're going to start with, which is the Eaves Haunch connection. So the idea is to try and create that. Remember, bear in mind that this project was done in Tekla structures, so there might be a few discrepancies here and there, but the idea is to create something like this and also give you the how-to in advance too. So let's dive in and we go to our connection vault. Now, under our connection vault, we want to go to column dash beam. This is what we want because we are connecting a column and a beam. All right, so we go to column and beam. We go to the first option. First option says Eaves Haunch to flange. So which is what we want exactly. Our Eaves Haunch is going to be connected to the flange of the column. All right, so let's activate that. Minimize that, select our column, enter, select our beam, enter. All right, so let's just give it a minute to refresh. All right, that's what we want. Okay, what's going on here? Okay, now I understand what's going on here. Our column is slightly shorter, so we have to extend it a bit so that it can come out the way we want. So let's exit this. Let's see if we can edit this from where it is now. All right. So let's do this. Hold the node of our column. Extend it somewhere by around 300. Say 300. Enter. Okay, so that's what you can do. Remember, you can edit the column individually because it did not come with the connection box. It did not come with the connection box. That is the idea of how you can edit that. So now instead of having to edit these other remaining columns one by one, what we can do is simply just delete our connection. Right. After we've deleted our connection, let's delete the base plates for the connection that you want to delete, because we want to delete them and then put it back as with the new height instead of increasing the height individually. So once we've done that, then we can delete these columns, because for us to get the height that we want, we have to add them manually. So from here now, what we can do is we can either copy this column as it is like this. Let's copy it with the connection from that corner to that node there. As you can see, it has gone with the base plate. But let's say you made a mistake, and which can happen. You can make a mistake at any time of the project. Let's say you were copying a beam or a column in any of the projects. For example, you can think that when you copy this column, right, when you copy this column to that node there, it's going to go with the connection for the base plate to the new position. All right, let's see what happens. So we copy the column, and mind you, here we just selected the column only. We did not select any elements of the base plate. So there, hit enter. So you see, it did not copy with the connection as well. So at first it copied with the connection, remember, because it's not connecting to any other steel section. We just added a base plate to a column. So that's the complete. It will copy if you copy the base plate and the connection as well. But if you are to copy, let's say it's beam to column connection, and you just want to copy the beam and the beam and the connection. The connection might not go to where you want it, because remember, you have left another element, which is the column. So bear in mind there. So let's just check what is happening with our column there? Okay, so you see, if I just zoom in there, you will notice that our column is not going straight to the grid line. It's not sitting exactly on the grid line. The center axis line is the one that is going straight to the grid line. So how do we remedy this? So what we do then is we double click on our column so that we can have this tab. Then we go to display type. And the display type, we did mention this. This is where now you can see how we can manipulate it. We go to exact with edge features. All right. So now exact with edge features, this is where you can see any feature that was added. So remember we had, when we were adding our base plate, we shortened the column by the thickness of the base plate plus 30 millimeters for grout. So by shortening the column, this is the feature that comes out, or this is the feature that is added to the column. So what we do now, for us to get back to the original length of our column, we just select this green feature and then we delete it. As you can see, our column has been extended back to the grid line. So let's just change back the display. Display type, then we go to standard. All right, then after that, what we do is we just have to copy, select, copy. If you know the distance between the grids, you don't need to exactly pick a point. You just pick a point anyway. Add your 5 meters, enter, add the second column, which is 10 meters, then enter. All right, then from there, we just mirror this to the other side, or you can copy it to the other side. It depends on what you want to do. So since we used a copy, let's mirror it this time. All right, so our base plates now, our base plates. So we just select remember the propagate command, just select the connection box, right click and say propagate. All right, so the base plate has been created. There we go. Now let's go to our haunch connection. That is what we are all about today. So from there, we go to connection vote, and then we go to Eaves Haunch connection. We minimize that, select the column, enter, select the beam, rafter, enter. All right, so this is what we have. So this is what we get. So now let's just move this by the side so we can have a clear view. Rotate this, have an idea of what it looks like from the inside so that we can navigate nicely. Okay, all right. So from here now, we go to general on our tab, right? So this is where you edit your haunch, your width and your length for your haunch. All right, so it says length from inside end plate face. So what it means that it from the face of the end plate going along your beam, that is the length that you want, which is this value here. If you check on our drawing, which is this value here, which is 1824, that is the length on the of the horn. So we go to general and we change that to 1324. All right, exactly. And then depth from the rafter bottom, that means from the rafter bottom going down. All right, we do not have that measurement. All right, so what we need to do is go back to our drawing, just check on our drawing. So when you take a look at the drawing on the left, on your right, we do not have that distance from the bottom to the end of the horn. So what can we do? I am using blue beam, so whatever amendments that I'm making, I can you'll be able to see when I measure or do anything. So let's try to just get the measurements, calibrate, then okay. So we just need to get a known measurement. let's start fresh, calibrate to ensure this right from there. We want to go to there. So this is Bluebeam, by the way. Bluebeam is a very, very handy software. You can measure, you can do estimation in Bluebeam. It's very handy software. So this measurement is 425. Yes, 425 millimeters, then apply. So let's just check our measurement. So from there to there, 425. Exactly, that's what we want. So let's try and measure the distance that we want. We want this distance here from there to that corner there. So we can say roughly, rounding off, just to one figure, that's 325. 325. That's the distance that we want. So we go back to advanced still. Depth from rafter bottom, then we can add our 325. Okay, that's that. Then corner finish at 3, we can leave it at 15. Corner finish chamfer 2, we can leave it like that. Then we go to additional plate. There's no any additional plate that we need there. Then we go to additional rafter. If you want to extend, if you have an overhang, you can add that. Then we go to our end plate. Our end plate, this is where we want. So the thickness of our end plate, if we check our drawing, the thickness of our end plate is a 12 mil plate. So let's put there 12 mils. And then we go to erection tolerance. Erection tolerance usually varies with standards and codes depending on which country you're from, but I'll say 2 millimeters is safe. So you can put 2 millimeters on either side of your rafter. So from there we go to end plate length type. So you can have projection, you can have exact value from the top, you can have exact value from the bottom. It's up to you. You can have projection as well. So it all depends on you. So if you say projection from the top, then what you do is you come here on projection top, right? So in steel detailing, there should be an allowance for welding. So you cannot have your end plate flush with the top or the top edge of your flange. For example, on your rafter, you can't have the plate flush with the top edge of your flange for the rafter. You have to either increase by a certain distance so that you can give allowance for welding, or reduce a bit so that you can have that allowance as well. So it is up to you. So usually I like to reduce the plate by 6 millimeters so we can allow for welding. And then projection at the bottom, as you can see, it says negative 214.80. We can say negative 6 as well. So there you go. And then end plate width type, right? You can say exact value or you can say projection. All right, so you're projecting. So this projection now, if you look at the picture here, 7 and 8, this is from the rafter, not from the column. The projection is from the rafter, not from the column. So this end plate is being referenced from the rafter, not from the column. So if your column has a bigger flange, that means that you will have to use end plate width type exact value. Then you enter the exact value. For example, maybe if you're using a universal column that has a bigger flange than your collar, than your rafter, then you have to use exact value. Usually that's how people want it sometimes. So it depends on how your project or your project type is. So here, projection, we do not want any projections. We just want the plate to flush with the flanges from the outside. So there, we don't want anything there. Then we say cap plate, then Cap plate confirmed, no trim. All right, we need this. We need this. We need this. Where do we sort this out? All right. Additional plate. At launch. This is not what we need. Additional rafter. This is not what we need. End plate. This is not what we need. Where, okay, our cap plate, why is it not highlighted? Why is it not highlighted? Okay, so all right, let's just uncheck this, and okay, this is what we need. So now it has been trimmed. So then we say either cap plate none, half, full, or by value. We want by full. And then the plate thickness, let's see if it has been indicated there, but that should be an 8 plate. That should be an 8 mil plate. All right. Then we go to plate width. Plate width should be according to the column, and the flange for the column, this one is a 178. If we go and check, our universal beam is a 406 by 178. So plate width, that's 178. Okay, that is what we need. Okay, plate gape, that's 4. Right, there we need 6. That's our welding allowance for weld allowance. Then from there we go to bolts and welding. So our bolting here, we've got 12 bolts, 6 on the rafter, and then 6 on the haunch. And then these bolts are M20 bolts at 80 cross centers. All right, so 20 millimeter bolt, that is correct. We don't want to change that. Bolt type, we need XOX, that's bolt and nut. So we just scroll down until you see this one that says XOX, or you can just find it here, or you can just type X. It's going to go straight to the XOX that we need. All right, then bolt grade, that's the one that we need, standard. All right, distance from previous bolt gauge, then horizontal distance, that's what we want. So your horizontal distance is this one here, from the other side of the web to the other side of the web. And here we've got 90 and we want 80. So let's put 80 there. And then number per side, it's 1. So we've got 1 on each side of the flange. Okay, so let's go to bolt groups. Now, here, what we have here, we've got lines of bolts. All right, then we've got start, and then we've got intermediate. So as you can see here on group 1, it says 3 lines. And group 2, it says 1 line. And then the start distances and everything, as you can see. So what it means is group 1 is bolting, is on the rafter. Then group 2 is on the haunch. So if you check group 1, bolts that are on the haunch, you have got three lines that are within the rafter, the flanges of the beam. We've got 3 lines, and then on the haunch we've got 1. So what we need to do, right, is to check our design. So on the beam, yes, we've got 3 lines. That's exactly what we want. And then the start distance is 55. That's the start distance. And then the intermediate distance is 90. So we're going to leave it like that. Then we go to group 2. Group 2, we've got 3 bolts as well, 3 lines as well. So we change group 2 from 1 line to 3. And then the start distance, this start distance is the start distance from the last bolt of group 1. So that's the last bolt, the bottom bolt on the that's connecting, that's within the flanges of the beam or the rafter. So we have 130. So we change 100 to 130. And then intermediate distance, we have 90. So that is what we want there. That is what we want. Then from there, we add our stiffener on the column. This stiffener on the column comes with from this connection. So we can standard weld 6 millimeters. That's what we want. If you've got welding preferences, this is where you change. Additional welds, you can add them there. Reinforcement plates, you can change them there. We don't need to worry about that because it's not part of the scope. Bolt and holes, we don't need to. You can either make the hole slotted, it's up to you, but here we don't need to worry about that. Then stiffeners, here this is where we need to edit. If you check, there is a stiffener on the column, which is this one here. All right, and then there is a stiffener on the rafter, which is that one there. So we need to add these two stiffeners. Right. We are going to add a stiffener, but the stiffener, as you can see, that's exactly from the edge of the rafter, in line with the edge of the rafter. It's just covered by the pay line. But if you check, there is a hidden detail there. So there is another stiffener there that we are going to add. So let's add those stiffeners. So stiffener 1, as you can see, it advanced. What's nice about advanced, it tells you, it gives you a description and location of what you want. You can check stiffener 1 and check on the picture. So we don't need stiffener 1, we need stiffener 2. That's the one that's hidden behind the pay line. So we go to stiffener 2 and we say full, because we want a full stiffener. Right there, as you can see, your stiffener has been created and the thickness is 10 according to our description. That's item 10. All stiffener plates to be 10 thick. Okay, so from there, if you want to make it sloped, that's where you can make it sloped. This one is not sloped. We go to stiffener number 3. It's a full. You want it there. It's not sloped. That's it. Then we go to stiffener number 4, the one that is supposed to be on the rafter. Then it's a full stiffener there. That's what we need. So stiffener chamfer, if you want to chamfer it, so you can play around with this and modify as you want. So we want to go back to bolt group. That's fine. General end plate is supposed to be, cap plate rather, supposed to be a 10 thick, not an 8 thick. It's supposed to be a 10 thick. Okay, so from there we are done with our haunch connection. So from there, remember, select the connection box, right click and say propagate joint. Just give it a second to load. So there we go. That was nice. So our connection box, our haunch connection has been created. That's it for this tutorial. Then on the next tutorial, we're going to focus on the apex connection. It's going to be fairly easy since we have seen how we manipulate this one, the haunch connection. So it's not going to be hard, since we have had a bit of some training on how to create a connection as well. So see you on the next episode.